Dear friends, this is the continuation of our previous gas turbine cycle analysis. That means we are discussing on the performance aspect. So we have seen in our previous class how the that means pressure ratio and temperature ratio. So nothing but T3 by T1. So how it is involving in the performance. So now we'll see one thing, that means how to obtain the maximum specific work. So because for obtaining the maximum specific work, so we need to have a certain condition. So the condition is nothing but so that means for certain pressure ratio only the specific work output will be maximum. Okay, so what is that condition? So that condition we just see yeah, that condition, whenever if you want to have this term, this quantity to be maximum, so it means we need to say at particular pressure ratio. So at particular pressure ratio, this will be maximum. So at what pressure ratio it is becoming maximum, so that is we just saying as the optimum pressure ratio. So at the optimum pressure ratio, this specific work output will be maximum. So so it means how this quantity. So optimum pressure ratio. So we just say this quantity is whenever it is optimum. This quantity is optimum, then this will be maximum. That is the idea. So because generally we can just say 1 by if it is maximum, then this quantity so will be smaller, the ratio will be smaller, so 1 minus smaller will be larger, so then so it will be maximum. Then here also when this quantity is maximum, then this minus 1, so automatically this quantity will be so this also will give the maximum. So the combined effect of this equation will give the maximum when there is a optimum pressure ratio. Because for given T, so that is also we have to understand. So for given T, there is a particular pressure ratio. For given T, there is a particular pressure ratio at which the specific work output becomes maximum. So that is what here we are seeing, because this value, this quantity, this one we are fixing it, and then this these two this C or the pressure ratio we are optimizing. So that how will we be finding the optimum pressure ratio? So maximum specific work output is achieved. So when pressure ratio, when RP becomes RP optimum, that is the idea. So for a given T, maximum work output is achieved when RP equal to RP optimum. So how to find out the optimum pressure ratio? So that is next thing. So optimum pressure ratio can be found out by differentiating this term. So we can just say that differentiation of this term with respect to C, so then we will be getting so by dc. So if you differentiate, then we will be having this one. So this quantity t into 1 minus 1 by c minus c, so when we differentiate and we give it to 0, then from this we will be getting the pressure ratio relationship, that is what called optimum pressure ratio. So by doing the differentiation, so what happened after doing the differentiation and equal to 0, then RP optimum becomes, so this is T3 by T1 whole power, that means so this is gamma by 2 into gamma minus 1. So it means, so this is the condition. After differentiating and equating to 0, this is what we are achieving. So it means our C, okay, RP optimum is nothing but root T, because this is okay root. So we can just say here it is nothing but yeah, because RP power 1 by yes 2 into yes, this is this. So when okay, this is what okay we are getting. So that means yeah, this is when T equal to this, so then we are achieving, when T equal to this condition, then we are achieving the optimum pressure ratio. So optimum pressure ratio is nothing but this one, RP equal to this. So at this condition, our specific work output, okay, so this specific work output becomes maximum, okay. So that is what we have to understand. So then okay, suppose if we want to have this condition, then okay we can write, so RP this okay equal to, so T3 by T1, so we can write T3 by T1 equal to, that is will be equal to, so T3 by T4 into T2 by T1. So this is, suppose if you, this is what nothing but T, so this is nothing but T. Suppose if you want to have this one, then T2 T4 should be equal to T2, that is the idea. So T4 will be equal to T2. So it means maximum specific work can be obtained when the turbine outlet temperature is becoming equal to compressor outlet temperature. So because whenever okay these two are equal, then only we can say T3 by T1. That is what okay here we are obtaining. Okay, so this condition okay for maximum specific work output. So this condition also we can say. So then it happens at this pressure ratio, that means optimum pressure ratio. Okay, I hope okay how we are obtaining the optimum pressure ratio, and how okay at what condition, that means the turbine and the compressor temperature, turbine outlet and compressor outlet temperature, when this becomes equal, so how we are obtaining the specific work output, okay, that means maximum specific work output. So I hope okay this is clear.